I drove this robot around from my phone through its eye. I can even program it through its app and let it follow the program. About $37 in part, body prints in one piece, no screw. Let me show you. Robots that teach coding cost $100 to $400 and lock you to one app. I am going to build something that does more. Drive, see, and code for about $37 in part, and you never open a code editor to build it. Here are the parts. An ESP32 cam, brain and camera in one, about $6, 4 gear motors, an L298 motor driver, a switch, a jumper wire, 2 18C50 cell, and the battery holder. About $37 all in. No specialty part, everything linked on the project page. Now, here is something nobody else does. The chassis is a single 3D print, designed from scratch, print flat on any printer, no support, no overhang. Every component snaps into its own slot. Motors, driver, camera, batteries, switches. No screw, no tool, no glue. The STL comes with the project. Alright, the next thing is the build. But before we get started, it's important you understand how the circuit diagram works. Let us start by talking about the motor driver. It is like the hub to every other components on the rover. We have 4 categories of connections to be done on the motor driver. The first is what I will call the actual driver connection, made up of 6 terminals. The second is the power connection, made up of 3 terminals. And the last 2 is the motor connection terminals, 2 on each side. We have 4 motors, 2 on each side, motor 1, motor 2, motor 3, and motor 4. Then we have the ESP32 cam, which is the brain and the camera in one, then the switch, and then the battery in series. The series connection of the battery has already been taken care of by the battery holder, so we now have just 2 terminal outputs, VCC and the ground. Now let's talk about the motor connection. Very, very important. We have 2 terminals on each motor. I named them terminal 1, terminal 2 for motor 1, terminal 1, terminal 2 for motor 2, down to motor 4. Now we're going to make the connections in such a way that we have just 2 wires coming from the left motors and just 2 wires coming from the right motors. To achieve this, we are going to connect the terminal 1 of motor 1 to the terminal 1 of motor 2. Also, we connect the terminal 2 of motor 1 to the terminal 2 of motor 2. So with this, we now have 2 meeting points, the center where we have 2 wires coming out of the left hand side. So we do the same thing to the right hand side. Terminal 1 of motor 3 connects to terminal 1 of motor 4. Then terminal 2 of motor 3 connects to terminal 2 of motor 4. So with that done, we now have these 2 points where it needed 2 wires from the right hand side is connected. So all of these result to us having 2 wires on the left hand side, 1 and 2, and 2 wires on the right hand side, 1 and 2, which is then connected to their respective output on the motor driver, labeled out 2 and out 1 on the right hand side, then out 4 and out 3 on the left hand side. The next connection to be made is our switch. One terminal of the switch is going to be connected to the positive terminal of the battery, and the second terminal is going to be connected to the VCC input of the motor driver. The next is the ground. The ground of the battery, which is the black wire, is connected to the ground on the motor driver. Then we connect the 5V terminal on the motor driver to the 5V terminal on the ESP32 cam. It is an output, and it is a well-regulated 5V output, good enough to power the ESP32 cam. And let's not forget to connect the ground of the ESP32 cam. It shares a common ground with the battery terminal, the battery ground terminal. Then the enable pin. The enable pin A and B is tied together and connected to the GPIO 12 of the ESP32 cam. And next we have the in terminals from the motor driver, the in 1 down to in 4. The in 1 is connected to GPIO 13, in 2 is connected to GPIO 15, then in 3 is connected to GPIO 14, then in 4 is connected to GPIO 2. Now let's get into the build proper. The first thing to do is to attach wires to the motors. Most of the time they don't come with wires, and this is how I attach them. I just tie them in and they are good to go. But if you are comfortable with soldering, You can do a little bit of soldering on the wires to the motor to give it a little bit more of mechanical strength. If you followed the circuit diagram explanation in the previous section, then this build should be just a walk in the park for you. The whole build is one continuous shot. Snap the motors in, wire each pairs to the driver, plug the camera in and wire it to the driver, the batteries into the switch into the driver. Follow the diagram in the project page. It's 2 ground wires, 2 power wires, 6 signal wires, from print done to robot done, faster than unboxing a commercial kit. Sit back, enjoy watching me build it, and follow along. nobody else does either. I head over to iotvh.dev and open the rover's project page. Once the rover project page is open, plug in the camera to the laptop over the USB port via the camera flashboard or the camera shield, whichever one you call it. Once the board is connected, click on flash firmware, click on connect device and select the ESP32 device from the pop-up. Then click on the flash firmware button. The browser writes it straight to the chip. No Arduino IDE, no driver, no code, bar feels done. The robot brain is live. While you are still on the page, just by the side, you have the download APK button that you use to download the robot companion app. And after that, you just scroll up and you have the STL file that you can download for the printing of their chassis. Alright, now let's drive it. Open the app. Hit find rover, it scans Wi-Fi and find it automatically. Connect and you're seeing through the robot eyes. Live with signal and frame rate right on the feed. Joystick to drive, button for the headlight. Tap to grab a snapshot straight to your phone gallery. This alone is a fun afternoon, but this isn't where it stops. Now another part that makes this more special. I hit record and just drive normally like a toy. I stop. The app has turned everything I did into code blocks. I can change one, hit run, and the robot does it again. A kid drives it for fun and walks away holding their first program. That's the whole point of this build. Now the code mode. Open code mode, then let's build some code ourselves. The forward block adjusts some of the parameters. The backward block adjusts some of the parameters. Turn right adjust the speed, the duration. Then we turn on the light for a while, wait for a while, turn it off. And then let's try to go forward, then click on run. And you see it's just going to run the program according to how it's done. And you observe that as it is running the program, it's going to light up each block. Then we are on the forward with the backward, one after the other till the end of the program. Here is the best part. For just $9.99 as a one-time purchase, no subscription, you get 3 things: the firmware, the 3D printable chassis, STL file, and the Android app. The app is available as a direct download from the project page, so you will need an Android device for this build. Comparable commercial robots that can drive, stream live videos, and teach programming typically cost anywhere from $100 to $400. If you would like to build your own, the link is pinned in the description below. And don't forget to subscribe, because in the next build, I will show you another project you can flash straight from your browser with just one click.